In grade 11, we are introduced to a new concept, and that is the concept of a surd. And so we're just going to start by looking at what a surd is and how to simplify them. A surd is essentially a number like this written underneath a root sign, and this number, there is no perfect cube root of 7. And so if we were to calculate this, we would end up with an irrational answer of 2,64575. So if you remember back to our number system lessons, we would have learned that an irrational number is a number that never stops and is not recurring, so there's no pattern. So because it becomes an irrational number like this, we often find it best to leave our answers in surd form, meaning that we would rather leave the 7 inside of this cube root because it is a more accurate representation than if we were to round off to 1 or 2 decimal places. What is helpful though is if we know how to simplify surds, because they don't always come to us in the simplest form. Take for example this number here, 2,800, and we want the square root of it. So this is not a perfect square number, which means I'm not going to be able to come to a nice easy answer like 50 or 7. But I can certainly write it in a way that there is just 1 digit inside of this root sign. Now we do this by prime factorizing the number underneath the surd. So when we were in grade 8, we would have learnt that we can do this ladder method, and we can say 2 goes into 2,800 1,400 times. 2 goes into 1,400 700 times. 2 goes into 700 350 times, and so on until we were left with only prime numbers. Okay, it's important to know this because these questions will require us to show all of our steps. But what we can do at grade 11 level is do this prime factorization step on our calculators. So what we can do now is we can take the 2,800 and we can type it onto our calculators, 2800. We can then press the equal sign, and from there we can hit the shift and this fact button over here. That will write this number as prime factors. So if I type all of that into my calculator, I will get the following. 2 to the power of 4 times 5 squared times 7 is all inside of a square root. And now it is easy to simplify this, because what I can do is I can take this inside power here and divide it by the outside square root. Or alternatively, if you think back to when we were in grade 8, we would have done it like this. We would have taken the 4 2's that we had, the 2 5's that we had, and the 7, and we would have made groups of 2, and wherever there's a group of 2, that would be a squared number, so we could take a squared number out. So the answer here would be 2 times 2 times 5, and because there is nothing to square there with the 7, that 7 would remain inside of the root. And so this big number here can be simplified to 20 root 7. This is the kind of question we can expect to see. So the square root of 75 plus 2 times the square root of 27 minus the root of 147. And so our first step should always be to rewrite our numbers with prime bases, because once we have prime bases, we can solve the root. So this is going to become, instead of 75, 3 times 5 squared. Then instead of 27, we can write that as 3 to the power of 3. And finally, instead of 147, we can write that as 3 times 7 squared. Now, wherever I have a squared number, I'm allowed to take it out of the root sign, because remember, a square and a square root cancel each other out, so that will move out. This 2 multiplied by 3 cubed is essentially going to be something that I can divide up into 3 squared and then a 3 that's left over, which means I can take one of these 3's out. So this is going to simplify now, and I'm going to end up with 5 root 3 plus, I already had a 2 outside of this root sign, and now I'm going to take out a 3, so it's going to be 2 times 3, 6, the 1 root 3 stays behind, minus 7 root 3. And now these function as like terms because they each contain a root 3. So I can add and subtract them just as I would like terms. So 5 plus 6 is 11, and 11 minus 7 is 4. And so our final answer here is 4 root 3. Now, surds are very closely linked with exponents, and that's why we're going to take some time now to revise the laws of exponents. When we talk about exponents, we often refer to things like the base, that's the number on the ground, the exponent or index, or even power, the number up in the sky. Okay, what something like this means, a to the power of 6, means a is being multiplied by itself 6 times. Okay, you'll see that most of these laws pertain to the bases. So we're always looking at what's happening with the bases before deciding how to apply our exponential law. The first one is that when we multiply the bases, so we've got the same base of a, these are being multiplied, the rule is that we add our exponents. So this becomes a to the power of 6 plus 3, which is simply a to the power of 9. Next, when we divide the bases, and this could also be written as a fraction form, it doesn't have to be that division sign, then we subtract. So we've got b to the power of 10 minus 7, which is b to the power of 3. Okay, when we raise a power to a power, we multiply the exponents. But what I see often is when we are given a number like this with a coefficient, students often forget that that also has an invisible exponent of 1. So when we multiply, we need to multiply that power into both of the exponents inside the brackets. So we're going to end up with 2 to the power of 1 times 8 multiplied by c to the power of 4 times 8. And that simplifies to 2 to the 8, c to the 32. Next up, we need to know how to deal with the exponent when it is a 0, and anything raised to the power of 0 is equal to 1. And this is such a helpful, almost exponential identity to remember, because this is going to come in handy when we start doing equations. Okay, when we are given exponential questions, we are always asked to leave our answer with positive exponents. So this e to the power of minus 2, I can rewrite as 1 over e squared. Okay, and if I had been given 1 over e to the minus 2, I could have rewritten that as a positive exponent by moving it to the other side of the fraction line. So in this case, the minus 2 moved to the bottom, became a positive 2. In this case, I moved my base to the top. That is now e squared over 1, which we don't often write. And then finally, roots, which we are going to use often now when we deal with surds. But what we use is we take the inside power and we divide it by the outside root. So this is going to become f with its inside power divided by its outside root as the exponent. In other words, f to the power of 9 over 3, which is simply equal to f cubed. Now, all of these exponential rules and identities are a recap from grade 10 work. But what we need to be able to do is to work with them and to combine them. So you may see some bases being multiplied, there's going to be a negative exponent there, and you're going to raise a power to a power. Or at grade 11 level, what we're going to find often is that we're going to deal with roots, and we're going to have to decide, are we going to leave them in surd form, or are we going to simplify with this exponential law of the inside power divided by the outside root? So let's look at some examples. We are told to simplify without the use of a calculator. Alright, now the fact that there are x's and y's and whatever, that already limits us. We can't use our calculators even if we wanted to. So what we need to do is we need to start applying our laws of exponents. But we are not able to do that until we have prime bases. So if ever you get given an exponential question and you're not sure where to start, you should start by getting prime bases. We can now rewrite this. So 2 to the power of x minus 1, 2 is already a prime number, so we can leave it as that. Multiplied by 8, we can rewrite 8 as 2 to the power of 3. And that is going to be raised to the power of 2x. And finally, in the denominator, 4 can be rewritten as 2 squared, and that is going to be raised to the power of 2x minus 2. So now what we can do is we can say this is 2 to the x minus 1 multiplied by 2 to the 6x, 3 times 2x, over 2 to the power, and we're going to put this into both terms there, so it's going to be 4x minus 4. Okay, now we've got two rules at play here. We've got multiplying the bases and dividing the bases. So the rule says when I multiply the base, I add my exponents, and when I divide the base, I subtract exponents. Okay, I'm going to do it all in one step. Watch closely. So in our numerator, 2 to the x minus 1 plus, because we are multiplying by the next 2, 6x, and then minus, we're going to divide by the 2 to the 4x minus 4, so we're going to subtract 4x minus 4, and now we can simplify this. So 2 to the x minus 1 plus 6x, let's multiply that negative into the bracket there. We end up with minus 4x minus 4, and that gives us a final answer of 2 to the power of 3x plus 3. Now let's try another example. We've got 3, that's a prime number, to the x plus 2 times 9 is not a prime number. We can rewrite that as 3 squared, and that will be raised to the power of x plus 1. Over 27, also not a prime number. We can write that as 3 cubed, and that will be raised to the power of 1 minus x. Okay, very similar to what we just did. 3 to the x plus 2 times 3 to the 2x plus 2 over 3 to the 3 minus 3x. And now I'm multiplying the bases in the numerator, so I'm going to add those exponents, and I'm dividing by the base in the denominator, so I'm going to subtract that exponent. So this is going to become 3 to the x plus 2 plus 2x plus 2 minus, be careful when you subtract, you're going to have a sign change. Always use brackets there. Okay, that's then going to be 3 to the x plus 2 plus 2x plus 2 minus 3 plus 3x. And then if I collect my like terms, I'm going to have 3 to the power of x plus 2x is 3x, plus another 3x is going to be 6x. And then 2 plus 2 is 4, 4 minus 3 is 1. So we're going to end up with 6x plus 1. Now let's tackle some grade 11 questions, and these are dealing with surds. Okay, the first step is going to be very similar. We are going to find our prime bases. 125 can be rewritten as 5 to the power of 3, m to the 12, and that's all in a cube root, minus 9, we can rewrite that as 3 squared, m to the power of 8. Okay, we are dealing here with a cube root and a square root. So when I want to write these numbers outside of the roots, I'm going to apply the rule that says you take the base and you take the inside power divided by the outside root. And then I'm going to do the same thing with the base of m, the inside power divided by the outside root. And then we're going to apply the same law to the square root over there. So 3 to the power of 2 divided by 2, m to the power of 8 divided by 2. And now we can simplify that. So 5 to the power of 1, we don't need to write that 1, m to the power of 4, minus 3 to the 2 over 2, and then m to the 4. And now since those are both m to the 4s, those are like terms. And so we can say 5 m to the 4 minus 3m to the 4 is equal to 2m to the power of 4. Alright, we can apply the same law here in the second example. So we're going to take a to the power of inside power 8 over outside root 3. Okay, that doesn't simplify to a beautiful fraction, but don't worry because there's something more happening here. Okay, there are more a's coming, so we might be able to work with it later. Alright, times by b to the power of 5 over 3 multiplied by. Now here's a 64. Let's quickly write that with prime bases. 64 can be expressed as 2 to the power of 6. So instead of 64, we can actually do that step where we use our prime base. So we've got a base of 2 to the power of inside 6 over outside also a 6. Okay, multiplied by a to the 8 over 6, b to the 2 over 6. Okay, and now I'm going to go back to my laws of exponents that tell me that if the bases are the same and they're being multiplied, I can add the exponents. So I've got a base of a base of b, and we also have this base here of 2, which there's just the 1. Okay, so 2 to the power of 6 over 6 is just going to be 2 to the power of 1. Then we're going to have a to the power of, and we've got 8 over 3 plus 8 over 6, multiplied by b to the 5 over 3 plus 2 over 6. Alright, now what I'm noticing is in order to add these fractions, I'm going to need a common denominator. But I can see that this fraction here can be simplified. 2 goes into 8 4 times, 2 goes into 6 3 times. And same thing here, 2 goes into 2 once and into 6 3 times. So if I were to simplify those fractions, 4 over 3 and 1 over 3, what I notice is that I can, in fact, add these like terms. So let's do that. We're going to have 2 to the power of a, and now we're going to have 8 plus 4, which is 12, over a common denominator of 3, and b to the power of 5 plus 1, which is 6, over 3. And then just a final simplification step, 2a, 12 divided by 3 is 4, b to the 6 divided by 3 is 2.